back sponsors, parents, and supporters to the Auburn University Formula SAE podcast update. My name is Payson Williams, and I will be talking with team members about the design process, design goals, and talk about what's going on in the shop. For today's update, we will be talking about the electric team's merge into the Formula SAE team. We have Jonathan Ashworth, Drew Cookston, and Stuart Coates.
So we recently made the decision to merge the two Formula teams, both the combustion and the electric cars, to become one team that now builds two cars. One with a combustion powertrain and one with the electric powertrain. Auburn University had a Formula electric team separate in its own accord. They had their own shop, they had their own design team, they had their own leadership structure, and their own budget and everything. They were a completely separate entity from the combustion team. And obviously, they ran into a few problems. They didn't have the years of experience and structure to fall back upon. They didn't really have as much overall direction as they should have had, and it didn't end up as the department had hoped. And they came to the end of the year, they actually didn't finish their car in time for competition. So they came really close and worked really, really hard, but couldn't get it done in time and couldn't get onto the track. And so they came to a turning point, and we decided that in order to keep the electric program going and keep Auburn on the map in the electric vehicle competition, we decided to actually merge the two teams to build a combustion car and an electric car, but under one team. We really felt like that doing this would solve a lot of the problems that we had. We could give them the direction and the structure that they needed and the overall purpose that they kind of lacked, and hold them to the same standards that we hold our engineers to, and pull them up to the level that we've been used to in the last couple of years. And we also felt like adding this to our program would be a good thing in the long run, both for the combustion team and the electric team. We felt like they had things to teach us and we had things to teach them. So we really felt like it was a beneficial grouping, and we feel like we can learn a lot from each other. And we're really excited to see what we can do, and really excited to see how this year turns out.
That was Jonathan Ashworth talking about the team merger. Now we're going to move on to Drew Cookston, who's going to talk about his role on the team.
My name is Drew Cookston. I am the current Chief Electronics Engineer for Auburn University Formula SAE. What this means is that I oversee development and implementation of the electrical systems for both the combustion and electric vehicles, including the electric powertrain of the EV. Last year's car, the prototype EV15, is nearing completion as of the time of this recording, with completion planned before the end of September. From there, we'll spend some time testing and gathering data from EV15 while ramping up to development of EV17. Our timeline for that isn't quite set in stone, but we hope to begin design in mid-October to continue through late March and early April. Manufacturing should complete by late October of 2016, right when the combustion build begins. After extensive testing, we hope to take EV17 to Lincoln in mid-June 2017 and to Formula Student Germany in late July. From a chassis perspective, the electric vehicle is identical to the current combustion car. From a powertrain perspective, however, they couldn't be more different. The electric vehicle uses a collection of batteries, the accumulator, as a high-voltage energy storage device to drive a number of electromagnetic motors. A benefit of this drivetrain system is that braking energy, rather than being dissipated as heat, can be used to generate a back electromotive force in the motor that can recharge the accumulator in a process known as brake regeneration. This powertrain is capable of 4 motors, meaning independently driven four-wheel drive, capable of all-wheel drive torque vectoring, that's differing the torque delivered to each wheel, and traction control to improve the vehicle's launch, acceleration, and handling. At competition, the technical inspection for electric vehicles is identical to the mechanical inspection of the combustion vehicles, obviously minus the engine stuff, plus an electrical inspection to make sure that the vehicle is safe, including a rain test where the vehicle is sprayed with water at a rain-like consistency to make sure the water doesn't pool anywhere and present a hazard. Amusingly, while the combustion vehicles have a noise requirement to ensure they aren't too loud, the electric vehicles have a noise requirement to make sure they are loud enough to hear. For static and dynamic events, the electric vehicle and its design team are held to the same standards as the combustion counterparts, with the distinction that fuel efficiency is quantified by measuring the output of the accumulator during the endurance event, less any brake regenerated energy.
For last year's electric vehicle, what are the specs on the battery and the motor?
Last year's accumulator was rated at 300 volts, which is the standard for domestic competitions. It was capable of outputting 80 kilowatts continuously and summed up to about 5.3 kiloamp hours. The motor generated 107 horsepower at the wheels. 80 kilowatts of energy generated 107 horsepower at the motor. For future competitions, we're hoping to be able to design the powertrain to compete both domestically and internationally.
What is your design role on the team?
For EV17, I'm overseeing development of the tractive systems, which includes the accumulator management systems, motors, and motor control units.
Now we have Stuart Coates, who is the electronic vehicle chassis lead.
My name is Stuart Coates. I am the EV chassis lead for the 2016 Formula SAE team. I am in charge of EV chassis compliance and EV chassis manufacturing as well as design for this upcoming car.
What are some specific chassis requirements that the electric vehicle has that the combustion car does not?
Primary difference in the two chassis is that the combustion car can use their engine as a structural member, whereas with our accumulator, we can't do that according to the rules.
What's the status of the prototype electric vehicle? How many electric vehicle chassis personnel are in your division?
My division shares engineers with the current chassis division.
Are you the main person who integrates the combustion chassis for the electric vehicle?
Yes, that is my design role for the 2017 car. I will be in charge of integrating their design.
Are there any plans to use combustion's monocoque in the future for the electric vehicle?
We are currently planning to use the 2016 monocoque for our 2017 car.
That about wraps up the show. Thanks to everyone who's listened in, and thanks to all our sponsors and supporters. Goodbye.
Now this feels professional.